Mm-hmm.
Okay, so when you load the part and define the units, RhinoCAM will be automatically set to those units. So whether you can work in inches or you can work in millimeters. These are the two units you'll be able to work with in RhinoCAM. All right?
Yes, yes.
Okay. So once you load the part, first step is you want to make sure you're working in the correct unit. Down at the bottom, it'll display the units for you. It shows as millimeters. If you want to change the units, right click, go to unit settings, and you can switch the units to the units that you'd like to work with. Okay? And
Yes.
as you go into RhinoCAM, you will see that all of the uh, units for tool definition, all your parameters are automatically set to millimeters. So the first step is you go into the Program tab, you define your machine tool. If this is going to be programmed as 3-axis, 4 or 5-axis, you would select that. So depending on the configuration of RhinoCAM you choose to go with, you'll have access to different types of number of axes. So if you pick standard configuration, for example, you only have a choice of 3-axis machining. You wouldn't see 4 and 5-axis with standard. If you choose the Pro configuration, you can program all the way up to index 5-axis. You can also do advanced 3D machining. You can do 4-axis as well. The Expert configuration includes 2, 3, and 4-axis. Okay?
Yes.
Now, can you tell me what type of CNC machine tool you're going to be using?
It's 3-axis.
3-axis. Do you happen to know the name of the CNC machine or the controller?
No.
Okay. All right. So once you have the machine or when you decide what you're getting, you will have to select the post processor from the list in here. Now, for the purpose of our demonstration today, we'll just go with the standard post. We can select maybe a Fennec controller, a standard G-code output. You can select the file extension, NC. The next step you want to do is define your stock material. Select stock, box stock, and this will automatically take a look at the part that you designed, and it gives you the minimum dimensions that you need to machine this part. It gives you the length, width, and the height, which is the thickness. And you can enter in the dimensions that you have for the stock. For example, I could say my stock is going to be 500 millimeters by 400 millimeters and maybe 50 millimeters thick.
46 will be fine.
46. Okay.
46.
Okay. So I'll define the stock. So now you'll notice that the stock has been created, and it is 46 millimeter high. And since I put in 500 by 400, you can see the stock is larger. The next step is we want to align the stock to the part. Pick Align. I'm going to have the bottom of the stock flushed with the bottom of the part because your bottom of the part is flat, and then the top has curved surfaces or sculpted surfaces. So we align it. Okay?
Yes.
So now the stock is positioned in the center of the part. In the next step, you can specify the origin. Where wouldn't you want to put the origin? So you can pick Align. After you do the Align, you click on Set World Coordinates. You choose where you want to put the 0, 0, 0. I'm going to put it to the stock. I could put it to the top face, so that would be highest Z, which would be the top face, and then you can choose the location. You can put it over to the west, which is in the center line of this part, or you can put it to one of the corners if you'd like. You can put it to the southwest corner. So depending on where you want to put the XYZ0. Okay?
Mm-hmm.
And then you click OK. This will automatically transform your part and the stock, and it'll put it at the origin that you have in Rhino. Okay? So that's the location of your XYZ origin right in here. Okay? Any questions, sir?
It's okay. Until now, I have a little experience with RhinoCAM, but I don't know next step from there.
Okay. So the next step is you pick the material. In this case, I'll pick wood, or you can select the material from the list. You can also customize this to add your material types. Selecting a material also applies a texture of the material, so you can apply it to this texture in the simulation as well. Next step is we want to go ahead and define some tools. I have a library of tools loaded in here, or you can build your own tools of type ball mill, flat mill, corner radius, tools for engraving, chamfer, taper. You have all these tool types you can create. You can save them to a library as well. And then you want to go ahead and select a type of operation. So you want to first do a roughing and a finishing. Now, since this part has these curved top, right? It's not a flat top, it's a curved top. I would do a 3-axis operation. So we'll go with 3-axis, and I'm going to select roughing. Now, in the standard configuration, you have horizontal roughing, parallel finishing, horizontal finishing, radial, and spiral. With the professional configuration, you'll have access to all of these methods. The first step is to do a roughing. You pick a tool. I could say I want to use a 12 millimeter tool or a 20 millimeter tool. You can select the tool type.
I have 6 millimeter or 8.
Yeah, 6 millimeter, or you can change it 8 millimeter. You can add new tools in here. You can call this, instead of 6.35, you can make it 6 millimeter. You can change the tool parameters in here. So we'll change it to 6 millimeter. We'll say save edits to tool. We can also add a new tool for 8 millimeter as well. Okay, so that's how you define a new tool. You can save up new tools in here. So for this particular part, we'll use the 8 millimeter tool. You then set your feed speeds. You enter in your cutting conditions, like you can specify the cutting parameters in here for your roughing operations. You can specify the step overs. You can control your cut directions. You have the step down for cut levels, how much of material you want to take down per pass. You can specify these in here. You can control the entry and exit parameters, and also you can specify fitting parameters for arcs, and then you pick generate. So in this process, it'll automatically generate a 3-axis roughing toolpath by taking into account the part that you modeled and the stock that you defined. So in this case, you can see it's roughing out everything that's can be removed. That's the stock. You can see it's cutting all of these areas out, right? But we don't want to cut these areas.
How much time will take to this operation?
It depends on the feeds and speeds in here. So if you right click and go to information, it'll look at the feeds and speeds. So I'm only cutting at 600 millimeters per minute. It's going to take a long time. And also, we would not want to cut all of these into chips. We want to hold the part. So we want to put a boundary to limit the tool path to a certain area. So we can actually go ahead and select a boundary in here around the part, right? So we don't want to cut the entire area. So what we can do is say we can put a boundary, like an outline around the part. So I'm just going to make a new layer in Rhino, and I'm going to use a command called curve in a Boolean, and I can just basically select everything in here, and I just click outside. You can see it creates a curved outline around the part, and I can maybe offset that out a little bit by maybe 1 millimeter, for example, or 2 millimeters. Right? I'm going to create a boundary and offset it out right there. So now for the roughing operation, I'm going to go ahead and pick this boundary in here. So the tool path will stay contained to that area only. And you can see it's not cutting all the way around, right? It's not cutting the outside. So you can create boundaries in here to contain your tool paths. And now if you look at the time, go to information, you see it's just a little over an hour for the areas that it's cutting. Now we'll go ahead and run a simulation in here. You can apply colors during simulation. So there's your roughing path. And I can always run the simulation faster by doing a pause and simulate to end. So there's the roughing operation.
I tried this method in RhinoCAM 2018, 2018. Can you hear me?
Yes, I can hear you.
But the settings are different versus this version. It's not working. in this same way.
Yeah, I'm not sure how you programmed it, but as you can tell here, I'm just programming it live on this demonstration, and you can see that we were able to create a roughing pad. You would then want to go ahead and do a finishing operation. You could do 3-axis. You could start with a parallel finishing. And if you only want to do the top faces in here, you could just do the top faces. You can pick a boundary around the part to select the top faces, or you could do the entire thing by just selecting this boundary in here. I can pick the same boundary, and then I can go from a flat mill to a ball mill tool. If you have a 6mm or an 8mm ball mill, we can use a 6mm ball mill. So I'm going to pick a ball mill tool right here and select the 6mm ball tool that we have. Specify the cutting conditions, the cutting parameters. You can control your step overs in here. Specify how fine you want the cutter to step. And then you select generate, and that would create a 3-axis finishing toolpath. Now, if you want to avoid some of these areas from being machined, we can select a region to not cut into these areas in here. We can pick a region, so we can go back into the parallel finishing operation, and I can say select curve edge regions, and I can go ahead and select these areas to not to cut into. So I can pick those edges around the part right here. I'm going to pick this. You see right over there, I'm selecting a containment boundary. So I'm just selecting these areas so we can restrict or contain the tool paths to an area. So you can use boundaries for containing your tool paths to specific areas. So it looks like there's some gaps in the part right in here.
Yeah.
So, okay. So I'm just trying to select them by not picking those gaps on the edges. So this is how you can go about defining regions. Your regions could also be created as curves. In this case, I'm just taking or selecting the surface edges from the model. So now that I've picked the two areas in here, when I generate the toolpath, it's not going to go cut inside the pocket, as you can see right there. Okay? So that's how you can avoid areas from being machined. You can do the same thing for these areas too. You can avoid from the holes being cut right there. So once you're programmed it, you click on play, and that'll give you a simulation for the finishing operation. You can see it's doing a 3-axis machining as it's following the contour of the part. Okay?
Yes.
Yeah, so this is how you would go about programming it. So once you have programmed the finishing operation, you could go back and program those pockets, finish those pockets, open pockets, and then you flip it over. You cut the features on the back of the part, and then post-process the code out to your machine. You can output. So with the Pro, we can program multiple sites. You can do a pause, then pick simulate to end. I'm selecting simulated to end, so it basically runs the simulation all the way through to the end, so you don't have to watch the simulation in every step. Okay? So there's the finishing operation. Now you can go back and machine this pocket, and you can also program this pocket in here with a smaller tool. You can do a 2-axis pocket machining, and I can pick the flat. I can pick this flat face right here, or I can just go select a chain of edges in here, and then just clean up this pocket. So you can do a combination of both 2-axis machining and 3-axis machining operations. And I can pick this pocket too. So you've selected those features, I can go with a smaller tool, specify your cutting parameters. The pocket is at the bottom. The feature you select is at the bottom of the pocket. It says open loops found, so it looks like there are some gaps in there. What I selected may not be a closed curve, so that's why you're getting the open loops found. So one of the ways you could do it is you could do a duplicate face border in Rhino. You can pick those. Okay, this is not a planar face in here, so that's probably why you're getting that error message. So we can basically go ahead and create a chain and pick that chain around the part. So you can use the duplicate edge command in Rhino to create it. So you can use duplicate edge, and you can just go ahead and select these edges from the model. And then you can join them to be a closed curve because there are some gaps right there. It says 10 curves joined to one closed curve. Now I can go back in here and just pick this closed curve for containing the toolpath, and you have your pocket finishing toolpath. So that's how you go about programming it. Okay?
Yes. It's very easy to see.
Well, it is easy, as you can see here. You send us the file, and we are showing you how to program it on the demo. Likewise, you can do drilling operations for these holes using hole machining and drilling. Or if you do not have a tool that matches the size of these holes, you can do hole machining using hole pocketing or hole profiling for programming these holes. Now, once you program the top side, you can flip it over and machine the bottom side. And if you'd like to do this within the same Rhino file, without having to flip the drawing or the part in Rhino, in the Pro, we have this feature called creating a new setup, where we can actually rotate the coordinate system for machining by 180 degrees. So I've flipped the coordinate system for machining. So on your CNC machine, you'll be machining the first side and then flipping it over. And now we are ready to program the bottom side. So I'm going to select the same area right in here. I will put the 0 to the top and the lower left corner like we did before. And we can now create a roughing path, generate the toolpath. So we are now programming a roughing toolpath for the other side. So now the roughing toolpath has been generated. You will be able to simulate from multiple sides. With the Pro, you can see the roughing from the first side and the simulation from the other sides. So all I did was I rotated the view in Rhino. So you can program from multiple orientations by creating multiple setups inside of Rhino.
Can I use also other methods from this machining?
When you say other methods, yes, there are different ways you can program it. So, for example, one of the other methods is using an advanced 3-axis method called 3D offset pocketing. And I can use this to finish off these areas in here. So that's an advanced 3-axis method. I'll pick the ball mill 6mm, give it a step over, generate. So this was going to give a finishing toolpath for this area in here. So there's your 3D finishing toolpath. And then finally, you want to cut the profile around the part. After you program all of these features, you could add a profile and cut to clean up the profile in here, 2-axis profiling. I would like to cut this step on the part with the flat mill 8mm. And you can choose it's at the bottom, generate it. So that'll give you a profile cut to clean up that step right there. And then finally, you want to do the profile cut around the outside. You can make a copy of this operation. And then you pick the boundary in here. You pick the same tool. In the cut levels, you can specify at bottom. We have the thickness is 46 millimeters. You can go in steps of maybe 10 millimeters each and specify your parameters and generate the tool path. And we want to make sure that the cutting is on the outside. So that'll give you a profiling operation. If you want to do bridges and tabs, you can do bridges and tabs to hold a piece with the stock material. So that's cutting out the profile.
And how can I add the bridges?
Okay, that's a good question what you asked. So we'll go ahead and define what is called a machining region by selecting this curve. And once you create a curve region, you can select what is called bridge points. You can do automatic bridge points. You can say you want to put 4 bridge points. And now you can go ahead and edit those bridge points to where you want them. So I can move the bridge points around. I can put one over here. I'll move this one over to here. And then I can move these where I like them to be. So I moved those bridge points. I can also move my start point around. So now I go back into the operation. I select predefined, select this curve. I specify my bridges parameter. I could say I want to do a rectangular bridge or a triangular bridge. I could specify that, give it a bridge height. I'll put in maybe 8 millimeters, bridge length, 20 millimeters, generate. So that would create bridges at those specified locations. So now when you run a simulation, you will notice those bridges being created.
These features are available also in a preview version of Rhino, the last Rhino.
So what I'm demoing here is RhinoCAM 2019 version. So this is the version that you'd be getting when you buy the software.
2018.
2019 is the current version.
Yes, I know, but I tried to make this G code in 18 version, 2018. A friend of mine have this program, and I want to know if I can make this settings from preview version of
You should be
this
able
Rhino.
to.
Yes, I tried, but these automatic features not working very well in preview version.
I've showed it to you in the demo here. So if you go back and try to recreate it the way I did it in the demo, you should be able to accomplish it.
Okay.
Okay.
Cool.
So once you have these operations programmed, you can look at the total machining time. Right-click information. Tells you the machining time right there. And then you can post-process this out to your machine tool. Right-click, you can select each setup and post them out separately, or you can post the entire job.
And how can I optimize this G code to move more faster?
you would have to set your feeds and speeds correctly. You can change your settings for the feeds and speeds. So in here, I'm just using the feeds and speeds that were set in the tool. I'm loading it here, but you can always use load from file and define the feeds and speeds based on the material you're cutting. So when I change it, it'll update the feeds and speeds, and then it'll recompute it.
I understand.
Okay?
Okay.
All right.
I will try to. I will try to make some features from you show me today. I will try, and in case I have no luck, maybe I can back to you again.
All right. Give me just one moment, please.
Yes.
So what I'm going to do here, Augustine, is